All right, welcome back everybody. So this is part 2 of our TE Cooler project video. Part 1 I'll link down the description below, as well as the TE Cooler basics video. All right, so where do we leave off? So last time we started the project for this miniature AC unit using TE coolers. And so we first designed the box using a 3D printer. We printed it using this PLA material, and we even waterproofed it using Flex Seal. The problem is that unfortunately it melted a bit in the sun because we didn't pay enough attention to the material properties of PLA. We went ahead and we fixed that. We printed with another material called PETG, which has a higher melting point and should work better for us. So let's get back into it. Okay, so first we're getting all the materials together. So obviously we need the box itself and the lid. We need the aluminum heat sink you see there. There's some thermal pads in case I need them. I believe I ended up not using them, but I did use the thermal paste. Also, there's the large output fan that will blow the cold air out. I have the power supply coming in off camera, the TE coolers themselves, and I think that should be it. So let's begin our construction here. So first thing we're doing is we're putting the TE coolers on this big aluminum heatsink that I bought that should fit perfectly right into the enclosure. We'll see if my measurements were okay. I'm using this thermal paste, which helps to conduct the heat away from the TE cooler. So the hot side will go down, the cool side will go up. And this thermal paste just helps stick it onto the heatsink a little bit. And it also helps to make sure that there's no gaps that could disrupt the conductivity and the heat flow. What I'm also doing, just to be extra sure, is taping them down using this thermal tape. All right, now that we've got the TE coolers stuck to the block with the thermal paste and with the tape just for good measure, let's see if it fits in the enclosure. And fingers crossed, fits perfectly. All right, so good start to our project. Now let's go ahead and fit the external fan. So hopefully again the dimensions were right. And what I'm showing here is that if you don't know which direction the air is going to blow, there's actually a handy arrow on top of the fan itself to tell you, so it's kind of idiot proof. I'll show you an up close picture of that. But now we're just doing a fit here. And this fan came with tiny little screws that just weren't going to cut it up. Just dropped one, okay. They come with these tiny little screws that aren't going to cut it. So I'm going to need to get some new screws. All right, quick trip to Home Depot later. I got some longer machine screws and some nuts on the end to secure this fan and the grill. Here I am installing the grill, and that's just going to make sure that no one sticks their hand in there, some debris doesn't get in the fan, makes it a little bit more safe, and makes it look a little cooler and more professional. So here it is installed. Good to go, looking good. All right, so what I'm doing now is installing what's called a power jack socket. So this will accept the end of the power cable, which is just a very standard, I think it's may even be called like a stereo connector, but I think it's like 2.1 millimeters. It's a standard size connector, and this is a socket for it. So I'm gonna do a little test fit here. Fits perfectly. There's also a little nut on the inside that keeps it flush against the box. So it also has a little waterproof plug in it, which is the black plug you can see hanging off. So this is just kind of making things a little bit more professional. Okay, so now I'm gonna wire up everything together. I say everything, it's really just a couple wires. It's not a big deal, which is good because I'm not too great at soldering, but I can get the job done. So I go ahead and I do that, and then I do a function check. So I'm gonna plug it into my power supply, my variable power supply. I've got it hooked up to 11 volts, 5 amps, and that's what the TE coolers are rated for. So that was covered in the first video. Go back and look at that if you want to know more. Okay, awesome. So the first function check went well, everything worked. No fires, no explosions, no smoke. Always a good thing, never a guarantee. So went ahead and started to wire up the power socket. And so I just attached some wires to that. I could have wired the TE coolers directly to, and the fan directly to the socket, but I decided to be a little bit fancy. I'm gonna put some connectors on there, so that's what I'll show you next. And this will just make it easy to connect and disconnect things, make things a little bit cleaner, make things a little more professional. What can I say? That's the way I like to do things, do it the right way. Okay, so here you can see the connectors that I put on there. These are just crimp connectors. I believe they're called bullet connectors. Very easy to plug in and take out. I thought this was just a nice little touch. It makes things a little bit more robust. And then here you see the finished product on the outside. Now a function test for real. What you're gonna see here is I'm putting the ice down along the sides, and then I'm gonna put water on top of that. So have some nice cool ice water. This again will help to dissipate the heat, which will be generated rapidly from the hot side of the TE cooler. So you'll notice that when I pour the water in, I'm very careful to just fill it to the top of the heatsink and no higher. So we remember that the way these TE coolers work is that the hot end draws away heat, so the bottom in this case, draws away heat from the top end, thus making it cooler. That cool air is what I want that to radiate away. And then the ice water there is there to help keep the heatsink cool. So it's kind of a reservoir for the heat to flow into. Now it won't last for forever. The ice will melt, the water will increase in temperature, but I want this working as long as possible. If the water was to submerge the top of it, of the TE cooler, then it would stop working, because we know from the first video that once the two sides reach the same temperature, that this thing stops working and you could break it. It wouldn't be a problem with the water getting on the TE cooler itself. It's not like it's not waterproof or something. The problem is that then you wouldn't be dissipating the heat effectively. Now for the moment of truth, is it gonna work? All right, so I get my little non-contact thermometer out here. We see the room itself is about 74.8 degrees, almost 75 degrees, a little too warm for my liking. That's what we have this AC unit for. And so I go ahead and I try it on the output here. And what am I getting? Not too great. It looks like maybe around 69, 70 degrees. So clearly there is a cooling effect happening here, but not as much as I would like. So let's see if we can improve this in any way. So I'm trying to think about this and try to figure out what can I do. So it occurs to me that maybe the problem is that, yes, there's cold air being generated, there's no question there. I mean, the water itself is at 32 degrees because it's ice water. So there's plenty of coolness in the box, but it's not being expelled in a way that's efficient. So here's what I'm gonna do. I'm gonna try to put these mini fans on there. So they're 40 by 40 millimeters. They exactly cover the TE cooler. And what I'm hoping is that we can draw the air up. And of course, it's gonna go straight up. And then the fan will pull it out from the box and blow it out. Let's see if that helps any. Of course, it's gonna be a little bit of a pain here because I'm gonna have to wire up these fans with everything else. So a little bit more soldering, shouldn't be a problem. Alrighty, take number 2. Let's see if this thing works. So here's just a quick picture of the unit with the fans installed. Kind of looks a little bit cooler. Alright, so I go ahead and load it up with the ice water again. And this is later in the day, so the temperature's a little different. Now it's about 73 degrees in the room, much more comfortable. And then what am I getting for the temperature output here? Okay, a little bit better. So I'm getting high 60s, 69, 68. It's not a perfect temperature output, so you see it fluctuates a little bit, but even down to about 66. So that's pretty good. It's clearly an improvement, but I think we can do even better. Okay, small apology here. I wanted for this to be a 2-part video series, but it's just too long. I'm doing the editing now. I'm gonna break it into 3 videos, so I'll see you in part 3.